my gosh, it's 11 o'clock and I have both projectors on. Good Tuesday. I have very low expectations. Okay, well, welcome back. How was your weekend? Good. Are you all registered for a lab? Excellent. Well, this week marks week 2, and this is going to be our actual first week of content because we're going to be going through a regularly scheduled program. We have Solidworks scheduled for Tuesday, so we're going to be talking about Solidworks today. Your first homework assignments for Solidworks will be assigned later today, and that will be due in about a week. That's the end of the day next Monday. Your Thursday class will be MATLAB. You will learn about MATLAB. Your first MATLAB homework assignment will be assigned on Thursday, and that'll be due about a week later at the end of the day on Wednesday. Your labs will occur as scheduled this week, meaning you either have labs on Tuesday and Thursday or Wednesday and Friday. Your Tuesday or Wednesday lab will be your Solidworks lab. Your Thursday or Friday lab will be your MATLAB lab. And again, the intention here is in class on Tuesday and Thursday, we talk about the software in a general sense, talking about how to use aspects of it, how the features work. And then in your lab, you actually go through examples or ask the TA questions. Does that logic make sense? Okay. I'm going to be trying something kind of different this year. I'm going to be attempting to, okay, let me back up a second. I want you to be able to remember what we did in class. I don't have PowerPoints or something similar for SolidWorks because it doesn't really lend itself well to that sort of lecture. Instead, I think it makes the most sense when we're sitting in front of the computer interacting with it, and I'm explaining what I'm doing as we're going along. So I want to, A, make sure that you can recall things that we did in class so you don't feel like you have to grasp everything as we go through it, especially when we go quickly later on. 2, I want you to be able to see what we're doing. In the case of these projectors with the lights off, you can probably see what we're doing in an okay amount of detail, but if you miss a number or something, I want you to be able to recover. So what I'm trying is I'm live streaming what I'm doing on my computer on the ME212 YouTube channel. If you go to D2L and you click the YouTube channel button, you'll see currently streaming SolidWorks. If you click on that, you can see what I'm doing with a couple of seconds of delay. I don't have great Wi-Fi in here, so it's not the greatest quality, but hopefully that'll improve as we get further into it. Worst case scenario, I might be able to steal the wired connection from the computer in here. But my intention was for you to, if it suits you, the type of work that you do, have that open on another tab. So if you miss a number that I typed in, you can jump over and see that number play back a couple seconds delayed. Does that make sense? After class today, this video will be archived on the channel, so you can go back and watch it again. Yes? Perfect. I'm recording the SolidWorks window and microphone from the microphone on this actual laptop. It's probably not the greatest, but it's better than nothing. You'll have to forgive me, I got sick this weekend, so my voice isn't the strongest. We'll see how that endures the 50-minute class. Did you all have, I guess, reasonable time installing SolidWorks? Did it go well? Any big issues you want to talk about? Okay. Well then, if you open up SolidWorks, you should find yourself facing a window that asks you if you want to open up a previously accessed file, if you want to go through some of the tutorials, if you want to access a new part. I think that should look something like this. And I broke everything. Cool. I personally don't like this window. I prefer to be able to jump directly into files or open a new file. So I prefer instead, stand by, I prefer instead to not have it show this on startup and just to get rid of it entirely. I prefer to open SolidWorks with this screen. If we want to open a new file, we can just go into File, New. If you are wondering where File is, because you can't see it very well, if you mouse over the SolidWorks Word, it'll pop up with additional menus, and one of them is File. I personally prefer to click the pin on the right-hand side of this menu and have that part of the menu stay open all the time. That way, when you want to go to File, you can just click on File, and you don't have to wait for it to open or animate. You can also access the new file by clicking this new piece of paper icon. But whatever the case, when you click on New, you should be presented with one of three options. You have the ability in SolidWorks to create three different types of files. SolidWorks uses what it calls parts, assemblies, and drawings. A part is a 3D model, or 2D model actually, of a thing. An assembly is a combination of parts or assemblies. A drawing is a two-dimensional drawing, mechanical drawing, generated from a part or an assembly. So let's say you wanted to model, a mechanical pencil. You might model the individual components of the mechanical pencil, maybe the plastic tube, maybe the little spring mechanism, maybe the eraser, maybe the plastic tip, maybe the finger rest, the rubber thing. All of those components would probably be best suited to be modeled as parts. Then you would combine the parts in an assembly, and within the assembly you could define how the parts relate to one another. Are they always in constant contact? Are they allowed to move relative to one another? Do they have a mechanical joint of some sort? Those are the things that you can define in an assembly. Within an assembly, you can also reuse sub-assemblies, like if you were working at a trailer manufacturing company and you found yourself using the same parts multiple times in the same trailer, it might make more sense to combine them into an assembly and use that within an assembly. Maybe the wheel mounting mechanism with all the suspension and brackets that go into that are commonly used together in the exact same way. In that case, it might make more sense to use a wheel mounting subassembly and then to combine those together into an assembly. The advantage of modeling things individually as parts and combining them in an assembly is that you can use the same part multiple times and you always know that it's the exact same thing. That aids your bill of materials, that aids the manufacturing environment, and if you make a change to that part, it populates everywhere that part is used. Does that logic make sense? So whenever you want to make a 3D model thing from scratch, we're doing that in a part. An assembly is made up of things that you've already created. We're going to spend about 3 days on parts, about 2 days on assemblies, and a day and a half or so on drawings. We'll start with a part. If we click on part and hit OK, I'm guessing the next thing you're going to see is a prompt asking you to define a unit system. Probably going to say, what do you want to use as a default unit of measure? I personally prefer the millimeter scale, so I use millimeters, kilograms, and seconds, as well as the ANSI metric. If you want, you're welcome to use inch pounds, that's also fine. You can change that within each particular document, and you can also type in any unit that you want as you're defining the shape of something. So don't feel like you're constraining yourself to that forever. You can always change it. After you've defined that, you can see a blank, empty void that we can define a part in. SolidWorks' user interface is similar to Office. You have a ribbon at the top with little tabs. Things are sorted together by topic areas that you access with the tab. And then there's a hierarchy on the left. SolidWorks creates a hierarchy of features to generate a part. So you might start by imagining a solid block of material and then removing parts of it and then adding parts to that as you're defining the shape of something. The advantage of making that into a hierarchy is that SolidWorks generates your part from top to bottom, and nothing that you do is permanent. You can always delete individual features, you can roll back to a previous point in your part, you can make a change to something that had affected things after it, and it all populates new. It'll make more sense as we get into it, but that's what that box is on the left. The region on the right is where you'll actually be looking at the thing that you're creating. In general, parts are created using two types of features. One is an extrusion, one is a cut. Extrusions create material, cuts remove material. Today we're going to be talking about the linear extrusion and the linear cut. So if you were to imagine me creating a square in space and then sweeping that square through a region of space, I could define the volume that that square swept through as matter for some sort of shape. I can also define a two-dimensional shape and remove material as I'm sweeping through space. That's a cut. You make extrusions and cuts by first creating a drawing. You create drawings on planes. Those planes can be the default planes within a SolidWorks part. They could be a plane defined as the edge of another part, or it could be a plane that you define yourself. So let's start with an example. Let's say that we wanted to make a cube that was 20 millimeters on each side. So it's 20 millimeters wide, 20 millimeters tall, and 20 millimeters deep. One way to approach that would be to create a drawing of a square and then to sweep that square linearly through 20 millimeters of space. If we wanted to make that, we have to start with a drawing of a square, and our drawing has to be on a plane. Our drawing is going to be created inside of what SolidWorks calls a sketch. So if we click on the Sketch tab, one of our options here is Sketch. If we click on Sketch, that's the leftmost button under the Sketch tab, that'll create a new sketch, and it'll ask us what plane we want to create our sketch on. If I click Sketch, it'll highlight the 3 cardinal planes in a SolidWorks part. Every part, by default, is created with 3 planes already in existence. A top plane, a front plane, and a right plane. Each of them intersect the part origin. Because I'm creating a shape that is symmetrical, it doesn't really matter where I create my drawing of a square. I could create it on the top and sweep that through space to make a cube. I could create my drawing on the front and sweep that through space to make a cube. I could create my drawing on the right and sweep that through space to make a cube. I will arbitrarily pick front. So if I click on the front plane, SolidWorks will orient my view so I'm looking directly at the front plane, and it'll open up my drawing tools so that I can create a drawing on this sketch on the front plane. Does that make sense so far? Okay. My drawing tools include the ability to make lines, squares, circles, ellipses, curves, etc. I could create a square, for example, by clicking on the line tool, clicking out here in space, and then the next time I click will define the end of this line and the start of a new line. So I could click down here, and then I could drag off to the right, click again, drag up some distance, click again, drag back to the left, and click my starting point. You'll notice that as I'm dragging my cursor through space, there are little numbers that are appearing. That gives me an indication as to how long the line is that I'm creating. Don't worry too much about trying to hit those dimensions exactly. We can define the dimensions of things after we create our line. Furthermore, you'll notice that my square is terrible. The sides are nowhere near perpendicular. Again, I can define that after I create the rough shape. I personally don't like the fact that when you are creating a drawing, SolidWorks pops up with all sorts of helpful information. It tries to automatically define what it thinks is what you're doing. So if you're dragging something in a roughly vertical direction, it'll say, hey, are you trying to make a vertical line? Because I can make that vertical if you want. I'm right here, just making this a vertical line. If you want to make this a vertical line. I don't like that in most cases. It happens to be convenient for the case of a square, but I have intentionally drawn my square skewed so I can show you how to recover from that. So I'm going to click this end as the same as the starting of my first line, and because I've clicked onto the line again, SolidWorks has ended the line tool usage. You'll notice that the line tool has a lot of options available. I can tell it to only draw horizontal lines. I can tell it to only draw vertical lines. I can tell it to draw only construction lines, which are lines that aren't used in the creation of matter. But I'm going to exit the line tool, and I'm going to start to clarify the shape of my drawing. If I want this to be a square, I could start by making the top and bottom lines parallel and horizontal, and make the left and right lines parallel and vertical. The way that I do that is by adding relations to my lines. So if I click on one of these lines, let's say the top one, it'll ask me what sorts of information I want to define about this line. Over here on the left, I have the ability to define properties. If I were to add the horizontal relation, for example, it'll force that line to be horizontal. Solidworks will do what it can to move everything else around in order to accommodate the relation I just defined. It will do that relative to the relations of the other lines. So if I told it that this top line was horizontal, and I told it that this bottom line was horizontal, and then I clicked on this left line and said vertical, that would work just fine, because SolidWorks is able to move things around in such a way to accommodate that relation. However, if I were to tell it that this leftmost line needed to be horizontal, that breaks. You'll notice it popped up as yellow. It's unable to accommodate the relation that I just added. So it's warning me, hey, I can't do that. You need to look over these relations and make sure that that's actually what you want. So in this case, I say, you're right, SolidWorks. I didn't mean horizontal, I meant vertical. I'm going to click on this relation and hit delete. It'll remove that relation. I can add a new relation, in this case, vertical. So I drew my right line as I was arbitrarily defining the shape of my sketch. I drew that line on the right as a vertical line, so SolidWorks pre-populated the vertical relation. I get access to more relations if I highlight more than one thing at a time. I can do that by hitting Control or dragging through space. So for example, if I click on the top line and then hold down Control and click on the bottom line, one of my options is parallel. If I were to click parallel, SolidWorks will say, okay, I will make sure that those two lines are parallel. Now, I don't really need to do that because I've already specified that both of them are horizontal, so they will already be parallel. But I could furthermore define them as being equal, which would force them to be of an equal length, whatever that length is. Again, I don't actually need to specify that because I define the left and right lines as being vertical, which will force SolidWorks to make that square shape be equal lines on the top and bottom. But it makes a little bit more sense if I click on the line on the left, Control click the line on the bottom, and force those to be equal. Now I've actually got a square shape. You'll notice that as I've been adding relations, SolidWorks has been moving things around. It is moving anything that is not fixed or defined in order to accommodate the relations, and it's doing that kind of arbitrarily so far. You'll notice that my lines making up the square have changed in length pretty drastically. Because they're not defined, I could redefine them at will. If I click on the corner and drag through space, I can redefine the shape and position of the square because it's not yet defined. If I want to specify a length, you're probably going to be tempted, when you click on line properties, to add in a length under the parameters here. You'll notice that one of my options for line property is length. If I were to put in, say, 20 millimeters here and hit enter, it has resized the square to make that 20 millimeters. However, because that's not defined, it doesn't appear, and it isn't actually fixed. Like if I pin down the bottom left-hand side of the square and drag the opposite corner, I'm resizing my square, despite the fact that I told it, hey, that line length is 20 millimeters. That is not how you want to define lengths that are intended to be fixed, at least temporarily. Instead, what you want to do is use a dimension tool. You can access those underneath the Smart Dimension option here under the Sketch tab in the ribbon. If I click the arrow below Smart Dimension, it'll pop up all of my dimension options. I could define a horizontal dimension, I could define a vertical dimension, I could define a lot of other types of dimension. Or, if I actually just click on Smart Dimension, it will try to predict what I'm dimensioning and use the correct type of dimension for it. So I have clicked on the Smart Dimension tool. I'm now using the Smart Dimension tool. If I click on one of my lines, it'll pop up with the length of that line. Now, the next time I click will define where it sets that dimension. It doesn't actually matter where I click next. If I were to click another line right now, it would include that in the dimension. So, for example, if I click the top line and the bottom line, it'll pop up with a distance dimension between the two. So I could use that as my dimensioning of one side of the square. It doesn't really matter. I will just accept it because it's already here. So I will click arbitrarily in space, and I will set down that dimension. The next thing it does is pop up with a length. It says, how long do you want that dimension to be? Now if I say 20 and hit enter, it'll define the length of that square as 20 millimeters, and it'll resize the rest of the square to accommodate all of the relations that I've already defined. So because I told SolidWorks to make the left and bottom sides equal, it is now forcing the height of that square to be 20 because the width of that square to be 20 because the height of that square is defined as being 20. Okay, so now we have the size of the square defined. That's not good enough though. In addition to the size of the square, I want the location of the square to be specified. As a general rule, you want your square to be fully defined. That is to say, you want whatever drawing you're creating to be fully defined. SolidWorks does that by color coding. Because my lines are blue right now, that means it's not yet fully defined. An easy way to tell if it is fully defined is to click and drag on part of it. For example, if I click and drag, I can move this around, and SolidWorks allows me to move the square. That means that the position has not yet been defined. Now I know what you're thinking. You're thinking, but John, you've just drawn a square in space. Position implies a position relative to something else. What is there to define a position relative to? That's a good question. My position is defined relative to the origin of the part. I have to put the origin somewhere intentional. I could put the origin on the bottom left-hand corner, for example. I could put the origin on the top right corner. But for character building, let's put the origin in the exact center of my square. There are a couple of ways to do that. One way to do it, for example, would be to click on Smart Dimension again, click the part origin, and then click one of these lines. If I click the origin and the bottom line, for example, I can define a dimension between them. For example, I could say the origin and the bottom line should be 10 millimeters away from each other. That would put the origin in the center vertically. And I could go through that again. I could use the Smart Dimension tool, click on the center, click on the left or right sides, define that distance as also 10. And you'll notice that my lines have switched color from blue to black. That means its position and size is fully defined. However, this is not best practice. I want my origin to be in the center of the square. I don't want my origin to always be 10 millimeters from either side. I should assume when I'm creating something in SolidWorks that in the event that I want to change something down the road, it should accommodate what I actually want with as few additional edits as possible. For example, if this cube being 20 millimeters on each side wasn't actually what I needed to accomplish whatever purpose I'm creating the square for, if I needed to resize it down the road, maybe to 25 millimeters or 30 millimeters or what have you, all of a sudden the origin is no longer centered. So if I were to define the origin as the actual center instead of a distance and offload the math onto SolidWorks, then it could accommodate those changes down the road. So I'll get rid of these two dimensions. I'll click on 10, I'll hit delete. I'll click on 10, I'll hit delete. Now, if I wanted to define the origin as being in the center without giving it a dimension, one way to do that would be to add construction lines. When I was creating the line tool earlier, one of my options here was for construction. If I were to click, say, on one corner of my square, and then click on the origin, and then click on another corner of my square, and tell SolidWorks that these two lines should be perpendicular and of equal length. I do that by adding relations. I have clicked on one line, held down Control, clicked on the other line, and now I'm clicking perpendicular and equal. Now, that forced relation on those two construction lines has not actually clicked on the origin. Okay, so what I did there was I made two lines that are perpendicular and equal to some arbitrary point that isn't the origin. The way that I correct that error that I totally made intentionally as an educational opportunity is by clicking on the origin, control clicking the intersection of these two lines, and then saying coincide or add the coincident relation. Coincident means touching for the purposes of these sketches that we're creating. So now that has forced a line starting from one corner of the square to the origin, and then another line starting from another corner of the square to the origin to be perpendicular and of the same length, which forces the intersection of those two lines to be in the center of the square, and because that's coincident with the origin, forces that to be in the center of the square. Another option.
Did you have to say both perpendicular and equal, or did you just say equal length?
I could say equal length, but not perpendicular, but if I did that, then I could still move it up and down. Here, I'll show you. If I click on the perpendicular relation and delete it, I can drag the square up, and it will force the origin to be in the center horizontally, but not vertically.
What about if you had a rectangle, not a square, you want to say?
What was that?
If you had a rectangle, not a square, you want to say that would work for you.
Well, that leads me to my third option here. I personally don't like adding construction lines unless I have to. There are more elegant ways to do this without adding additional entities for SolidWorks to have to keep track of. So a third option here would be to avoid using construction lines. By the way, I could have added like a bunch of construction lines. I could have said a construction line from each corner to the origin and told them to all be equal. I could have added construction lines that were like in the center of the top, going to the center of the bottom, and then of the center of the right and the center of the left, and have those intersect and be perpendicular and of the same length. But what I would like to do instead is tell SolidWorks the center of the top of the square should be vertically aligned above the origin, and the center of the right or left side of the square should be horizontally aligned with the origin. So the way that I do that is by selecting the point that represents the middle of the line. The way that I do that is by right-clicking on the line and hitting Select Midpoint. So now my selection in SolidWorks is the midpoint of the line, not the line itself. And I can really add relations relative to that midpoint. So it is currently selected. That means if I control-click the origin and then add a vertical relation, SolidWorks will force the middle of that line and the origin to be above one another. So right now, I should be able to drag the square, but only in the up and down direction. If I repeat the process, right-click on one of the side lines, select midpoint, control-click the origin, add the horizontal relation. Now my square is fully defined in space. And I didn't have to add any construction lines. That method would work for rectangles. If you had a really arbitrary shape that didn't have nice, convenient lines to position the midpoint relative to the origin, you could always add construction lines. Like if I was trying to, here, let's go down a side tangent here. If I was trying to define the position of the center of a super arbitrary shape, like say, oh, this shape right here. I could position construction lines in space that aligned with the top and bottom of my part. I could add relations to the top of this construction line, force it to be horizontally aligned with the topmost part of my other sketch. I could say the bottom of this line and the bottommost point of this sketch, add those relations as horizontal, and then say the middle of this construction line and the origin are horizontally constrained as well. Does that make sense? Okay. Any other questions? Okie doke. Well, now that we've actually got a square, we can sweep the square through space to create a three-dimensional entity. The way that I do that is with the extruded base feature. If I wanted to remove material, I would use the extruded cut feature. Extruded base and extruded cut sweep on a line through space. So I could click extruded base while I'm in the sketch. I could also exit the sketch and click on that feature. And then when it says, hey, what sketch do you want to use? Select sketch 1, the only sketch that exists. Solidworks is also pretty smart about those sorts of things. Because my part only has the one sketch and I tell it to create an extruded base, it says, I'm guessing you want to use that one sketch that exists. And I say, yeah, you're right. So it pops up with a little preview of what it's doing. It's sweeping that sketch that we defined through space and creating a three-dimensional entity from that resulting volume. How far do I want to sweep this? 20. So I could type 20 here and hit enter. And hit OK. And I would have a cube. By the way, if you want to rotate things on your screen, you can hold down the middle click of your mouse that I'm sure you all have for your laptops and slide around, which will rotate things. If you scroll in and scroll out, you can zoom in and zoom out. If you don't already have one, I would really encourage you to buy a mouse for your laptop. This is very difficult to do. But also appreciate it if you turn off your cell phone ringers. Very unprofessional to do. It isn't. Thank you. I have a cube. Good enough for the drawing that I created over there. However, I have a cube now that's positioned on the center, left to right, and on the center, top to bottom, but not on the center, front to back. I created my sketch such that the top of the plane, the top plane of my part is in the center because I created the square on the front plane and it was vertically centered around the origin. And the right plane is in the center because I created my sketch such that the square defined on the front plane was centered left to right. However, the front plane is not in the center of the cube because I extruded my square in one direction and it started from the front plane. So if I wanted to change that so that my cube was actually centered in all three directions, I could edit that extrusion to extrude one direction of 10 millimeters, the other direction of 10 millimeters, or I could also tell it to extrude equally so that the total dimension was 20. The way that you edit extrusions, the way that you edit any feature actually, is by right-clicking on that feature in the hierarchy and hitting Edit Feature. So it brings me back to where I was before. So if I were to change this to, let's say, 10, and it was extruding blind in one direction, and then add a second dimension that was also 10 in the opposite direction, that would be one way to accomplish a 20 millimeter total extrusion. However, there is a more elegant solution. That would be to extrude with one direction only, but choose midplane. So now it's going to extrude equally in both directions such that the total distance is whatever you specify. So if I said 20 millimeters here and hit the green check mark, now I've got a cube positioned so that my part origin is in the exact center of the cube. Does that make sense? Yes?
If you would have just kept it for 10, it's just going to be 10, right?
It would only be 10, correct. Would you like to see what it looks like with 10?
Why not?
Let's do it. I like it. I go back into editing my feature, change it to 10 instead of 20. Now I've got half a cube instead of a total cube. Okay, let's turn up the pace a little bit. If I wanted to remove material, maybe I want to have a cube, but I want to have a channel through the center that's a circle of 5 millimeters in diameter. Let's go back to a 20 millimeter cube, and let's remove some material. The way that I remove material is with a cut instead of a extruded base. So here, I want to use the extruded cut feature, which requires a sketch. So we have to create another sketch. If we go into Sketch, hit the Sketch button, it'll ask us where we want to create the sketch. I could choose one of the coordinate planes again, or I could choose one of the edges of my cube. I have to create the sketch on a plane. I can use one of the ones that already exists, or I could use a feature that I've already defined in my part. The advantage of using the coordinate planes is that they don't change. They are permanent. If I were to define the sketch on one of the edges of the cube, if the cube changed for any reason, my sketch might break. If you are designing a elegant sketch, you shouldn't have that issue. It should be able to accommodate changes in the cube, but let's just draw on the front plane for the purposes of an arbitrary example. Let's say I wanted to remove material in the shape of a circle. I would draw a circle. So I went to Sketch, I selected front plane from the tree. I'm now drawing on the front plane. However, my view is not looking directly at the front plane. It automatically moved my view so that I was looking at the plane I was drawing on for the very first sketch, but it doesn't do that anymore. Instead, it expects me to be able to move my view to wherever is most convenient. So if I wanted to look at the front plane, I could change my view to from the front. The way that you change your view orientation is with this center button on the little string of buttons at the very top of this window. If I say view orientation front, it'll move my view so that I'm looking at the part from the front. Because I'm drawing on the front plane, this is a very convenient place to be looking. So let's say I wanted this circle to be on the origin and to be, what did I say, 5 millimeters in diameter? Well, I created a sketch. I used the circle tool to define a circle. If you didn't see what I did, I'll repeat it. I clicked on circle. I clicked once to define the center of the circle, a second time to define the outer edge of the circle, but because I haven't actually given it any dimensions yet, that's arbitrary. I don't need to pay too much attention to the dimensions that I'm creating. By the way, that two-click method of creating a circle is the default, but it's not the only way of defining a circle. If I wanted to, I could select one of these other circle types. In this case, for the circle tool, there are two types. The first one, the default, uses 2 clicks. One defines the center, one defines an outer edge. The other option here uses 3 clicks. These 3 clicks would define 3 points that are coincident to the circle itself. So if I wanted a circle that intersected the outer edges of my square, I could select that option and then click on the outer edges of my square, and it would define a circle such that it intersected those 3 points. Some of the other tools have even more options than that, depending on what's convenient for the thing that you're trying to create. Okay, we've got too many circles. I delete one, go back to my first circle. First thing I want to do is center the origin on the center of the circle. So I will click on the center of the circle, I will control click the origin, I will add a relation. The relation that's relevant here is coincident. I want them to be touching. Next I add a smart dimension, I click on the edge of the circle, and smart dimension says, oh, I bet you want to dimension the diameter of that circle. And I say, that's right. So I click again to arbitrarily place that dimension, and it pops up with a distance. You'll notice it's a diameter, not a radius, as indicated by the diameter symbol. I want the diameter to be 5, so I hit enter. Click the green check mark to exit the circle tool. I can now create a cut using this sketch by going up to Features, Extruded Cut, and removing material in the same way that I did before. So because I'm removing material, and I want the cut to go all the way through this part, because that's the example that we're doing right now, I could say blind cut 10 millimeters, direction 2, blind cut in the other direction 10 millimeters. Again, I could do a midplane and say midplane 20 millimeters. Or, because I'm cutting, I could say through all. Through all would cut through all of the material that's there infinitely in one direction. Through all both would cut through all of the material that exists in both directions. Because I want a cut that goes all the way through everything, I'm going to select through all. I could also select up to surface, and then it would prompt me to select a surface to cut to, and then select a side. That also works. There are a lot of options, which we'll cover in more detail as we get further into this. I'm going to cut through all in both directions, and now I've got a cube with a hole through the center. Makes sense. Okay. Well, that's enough of this arbitrary example. Let's try something a little bit more realistic. Let's say I was asked to create a 3D model from a two-dimensional drawing. Let's say specifically this two-dimensional drawing. I've been given a mechanical drawing. It has a front view, a top view, a right view, and an orthographic view. My goal is going to be to create a part from it. I'm going to exit this part. I'm not going to save because I live on the edge. I'm going to go to File, New Parts, and hit OK. Where would you like to begin?
Sketch.
I like it. Sketch on what? And what should I sketch? Sure, I could sketch from the front, I could sketch from the top, I could sketch from the right. It doesn't really matter. There is no best choice here. It's all just what path do I want to take to my end result. I like it. Let's create a sketch in the front plane. So I'll go to Sketch, hit Sketch. It'll say, which plane do you want to draw the sketch on? I say, the front plane for no reason in particular. What shape should I draw on the front plane? The front view. All of the front view? Not the round shaft that sticks off to the right. Why not? I can add that later. Right. If I were to draw everything that appears on this front view, including that shaft that sticks off to the right, then when I sweep that through space, I'm going to have a weird rectangle sticking out the right side of my part. Now, I could remove material and leave the circle behind, but I could also just draw everything to the left of that part of the pin and then add that pin as an additional extrusion. Again, there's no best choice here. There's lots of paths to that end result. So I'm going to create a sketch of everything that appears on the left of this line right here, and I'm going to neglect this hidden line. So my shape is going to consist of 3 lines. I will allow Solidworks to add in the horizontal and vertical relations, and then I will add a circle on the left-hand side. By the way, I want to create half a circle, not a full circle. One option here would be to use the center point arc. The center point arc would define a subsection of a circle. Another option would be to draw a whole circle and remove everything that I don't want. Doesn't really matter what I do. I'll use the center point arc for now. The center point arc takes 3 clicks as defined by this little image here next to arc type. First click defines the center. Second click defines the start of the arc. Third click defines the end of the arc. So I will define the center of my arc. I will define the start of my arc. I will define the end of my arc. There, I've got exactly what I see over there, right? I mean, not really. I can add some relations here to make it a little bit more accurate. First thing I'm going to do is join my arc to my lines. I'm going to merge the endpoint of my arc, merge the endpoint of my arc with my line. I can force the top and bottom lines to be equal and or parallel and or horizontal. I could add a tangent relation between one of the lines and the arc. Heck, I could do it for both if I wanted to. I don't have to, but I could. And now we've got the rough shape. I could also add that circle, the cutout, on this sketch. I could also add that circle later on as a separate cut. I will add a concentric relation between this circle and this arc section, such that the center of the circle is now on the same center point as that arc. Now I've got the rough shape. Where should I position the origin? What do you think? Center of the hole works for me. It doesn't really matter where I put it. The point is just that it needs to be placed intentionally. As we get further along, once we start dealing with assemblies, the origin of the part is more important because that affects how you relate parts together in an assembly. If we were actually positioning this bracket so that the pin could mate with a hole on a different part, the origin position might be more important. But here it's arbitrary. So I'll position the origin such that it's on the center of this whole cutout. That's not what I wanted. Try that again. Click the origin, click the center of the circle, not the circle itself. Coincident. Now I've got it defined. Okay, now what? Let's add some dimensions. What would you like to dimension? Okay, could you give me a starting point? Diameter of the circle. So what's the diameter of the outer circle? It is not. 32. That's a radius as indicated by the R. By the way, just as a fun fact, I know how much you guys like fun facts. Because my unit system is defined as millimeters, everything that I add dimensions to defaults to millimeters. If I type 32 and hit enter, it'll assume I mean 32 millimeters. If I wanted to make this in inches, and I didn't want to change the unit system for whatever reason, I could actually just type 32 IN, and it'll figure out how to make that 32 inches. I could also type 32 M for meter, or 32 MI for miles. There's a lot of built-in units, and it handles the conversions automatically. What would you like to dimension next? That clock is slow. I keep forgetting. We'll pick this up next time. Control Z. The homework will be posted on D2L. It's creating a couple of simple shapes.
So do you want us to save this then?
You can if you want. We'll be picking this up on Tuesday. As far as we're concerned, the Solidworks lab, they're essentially next up. Okay. Is that your question? There's a computer lab that you use in cloud, but that's not the same computer lab as the general use mechanical engineering students. That one is now in my office. It's like 256. It's on the very it's the southernmost door on the second floor. Okay. Thank you. Every time I go inside, I just get you might have to start that works or doesn't work, let me know.
Okay.
That's what I did in my childhood. Playing games.
Did you get this from last time?
Okay, we are out of my ability to troubleshoot. Recommend telling this to
Alright.
and or Google.
Thank you. Okay, so I like everything went smoothly, download for everything. And then, sorry, like open it up and look through the next thing that you have. And then also just like kind of shut down off the page or whatever. And it was like this or whatever, and then it just went down. Then I went back on it, so it said it didn't have most papers, it doesn't work, so. Is that like something you need to like make sure you're not
So
connected to it, or
No.
why is it?
Solidworks is
Okay, first of all, let me shut this down.